So the next problem that we are going to tackle is question 21. And here the problem is as follows. A donkey is tied to a rope AB of length 3 meters. So here you have your donkey, very nice picture, and the rope AB is attached to it, and the length of the rope is 3 meters. And so, oops. Just one moment, please. Sorry about that. So this rope, the length of this rope is 3 meters. We'll just put 3 there. Okay, the rope is connected to a metal rod of length 12 meters. So the metal rod is CD. So here it is. And the length of this is 12. And the metal rod is fixed to ground at ground level. Okay, it's on the ground. But the rope can slide freely along the rod. So you can see a little kind of a ring here. So the rope can move along this rod. If the total possible area which the donkey can graze is A pi plus B, find the value of A plus B. So you need to calculate the total area in which the donkey can graze. So let's see now, how will this happen? Well, certainly you'll have the donkey if this rope is at this point and you want to show how far it can raise, the donkey will go right to the end of the rope. Let's suppose it starts here, right? And then it wants to maximize it, so it's not going to make the rope loose anyway. Okay, it's going to be quite tight. And suppose now it moves in this direction. If it does, it's possible for it to move so that this thing here is moved into different positions here. So you can have all these points where the rope is 3 meters long, can form a boundary. Every point here is attainable by the rope, but nothing beyond that. Okay, but the thing is that when it comes to this end here, then the rope can't be, even if the rope is taut, it's not moving anymore. It comes to the end. So now it will go in the form of a circle. Right. And when it comes to the other side, the same thing happens as what we have there. So all these points, so you got all these points here also are attainable. Like that. But from here onwards, you're going to get a semicircle because it can't go beyond the 3 meters. So you'll have a semicircle of radius 3, and here too you've got a semicircle of radius 3. All right, so in short, let's just redraw that diagram. So what you have, the area in which this donkey can be, we'll have a line like that. That's the top boundary. And then you have, let's give another color to the rod. And then you also have the bottom boundary. Wow. Like that. Now these are 3 meters away from the red line. And then after that you have a semicircle. I don't know whether I'm going to draw the semicircle accurately. Oh, wait a minute. Let me have a loose freehand. Okay. So it's not going to be very accurate, but you're going to have a thing like this. And then here too. And this is a semicircle. It starts here. Right, so the area in which the donkey can graze is enclosed by this black line. So we need to calculate that area. Now remember, this rope is 3 meters here, and it's taut at these places. And the rod is 12 meters. So you actually have a rectangle here. You have a rectangle in between. Like that. Like that. And the side of the rectangle is 6. And this is so this area here, which the donkey can graze in, is 72. We'll hold on with that. And now these two semicircles, they can be merged together to form a single circle. And the single circle is a circle of radius 3. Okay, so you can put this area here, match it with that one. You'll see that you've got a circle of radius 3, and you want to add the area inside that circle. Right? And the area of the circle of radius 3, the area of a circle is pi r squared, and so it'll be pi times 3 squared. Okay, and 3 squared is 9. So the area, the grazing area, equals the area of the rectangle, which is 6 times 12, plus, you could have half of pi times 3 squared, half here and another half, so 2 halves make a whole. Or otherwise, you can imagine both of them are merged together to get this area. So that's your grazing area. So that is 6 times 12 is 72 plus 9 pi. So there is a pi in the area, 9 pi plus 72. So this thing here is 9 pi plus 72. That's the area in which the donkey, 72. I think I'm dyslexic. So you've got the A plus B will have to be 9 plus 72. Those are the numbers outside pi. So the answer is 81. Okay, let's just check to see whether, oh, there it is. You can see the 81 hiding inside there. And let's just take out all these. And it's exactly the same argument that I used so far. Okay, so let's just get on to the next problem now. We're going on to question 22. There are 25 questions. So we've got 4 more. Oh. So here you have a kind of a wedge shape thing, but it's flat. Okay, so what have you got here? In the diagram, AC is perpendicular to AD, BD. Because AC is perpendicular to BD. Oh, this is AC. AC is perpendicular to BD. Right? Let's make this here 90 degrees. Okay. ED is parallel to AC. So you have, okay, these are parallel. ED. and AC. And you have AE is perpendicular to AB. AE perpendicular to AB. So this is 90 degrees, yeah? You have angle B is 45 degrees. Okay, that's shown, yeah? And DE is 6. DE is 6. So that's also shown. Now, they say determine the area of the trapezium ACDE. So the problem is to determine this area just of the trapezium. All right, so we can find the area of a trapezium. The formula for the area of a trapezium is this half the sum of the parallel sides. So it's half the sum of 6 and this side here, which we don't know. Okay, let's call this side here X. Right? And then the required area is equal to half the sum of the parallel sides, X plus 6 is the sum of the parallel sides, times the height between them, between these two parallel lines. And the height is here. See, these are 90 degrees. These are parallel, so this is also 90 degrees. Parallel lines, and those are co-interior angles. So this is 90, that will also have to be 90. Okay. And we don't know this length, it's not given. So let's just call it H. So we've got two unknowns here, X and H, and we need to calculate both these to get the area. All right, so, okay, let's have a look at this. You got X here. Now this is a right angle triangle. You got a 45 degrees. So this will also be 45. So it's a isosceles right angle triangle. Two angles are the same. So if this is X, so this will also have to be X. So you got that is X. Now, the area of this is given to be 25. So you've got a formula for X here, because the area of this triangle is half X squared. So you got half base. Let's take this to be the base, and this will have to be the height. So you got half X times X, which is X squared, is equal to the area of the triangle ABC, but it's given that the area of triangle ABC is 25. So you can calculate X. Okay, I'm just going to leave that calculation aside for the moment. I'm trying to calculate H. Now, it's not going to be easy to calculate H, but what we can say is the following. You see, this thing here looks like a sort of cut-off right angle triangle. Right? Let's just complete the right angle triangle just to explain what I'm doing. If I extend this line here, AE, and extend BD, okay, now you have a large right angle triangle, you see? And this angle here is 45. So let's extend it like that to see how we can use that. So this is 45. So this will also have to be 45. So this angle is 90 degrees. So this is 45. But now you've got a 90 degrees here. So that is also 90 degrees. This is 45. So this will have to be 45 because you've got a small right angle triangle with one of the angles 45. And that allows you to say that this triangle here, let's call this F, this DEF is a isosceles triangle, which means that DE is equal to DF. So that is 6. Okay. Now, oh yeah, okay. So this, you see, this angle, this triangle is also isosceles here. There's another right angle triangle sitting here. And this angle here will be 45. See? So I'm talking about FCA, the large triangle. There's 90 degrees here, there's 45. So this has to be 45. So you have another isosceles triangle, which is FCA. So CA is equal to FC. But AC is equal to X. So this entire thing is also going to be equal to X. Now that gives you H, you see. H plus 6 is X. So H is equal to 6 minus X. Well, at least X minus 6. Because when you add these two, you're going to get X. It's X minus 6. So this area here, the required area, we can now replace the H. So it's going to be half into X plus 6. X plus 6. And H is X minus 6. Now this is an old friend for algebra students. The X plus 6 into X minus 6 is half difference of two squares. That's X squared minus 36. And that is equal to half X squared minus half of 36, which is 18. See, we didn't calculate the half X squared. We didn't calculate the X, but we have an half X squared here, so we can, there was no need to calculate it. So 25, the half X squared is 25 minus 18, and that gives you 7. So it's a very beautiful problem. Without actually calculating X, we can calculate the area of the trapezium using the formula half the sum of the parallel sides times the height. So the answer to the question is 7. That's the area that you're looking for. Okay, so let's just check this thing out and see whether it is. So there it is. You can see in my prepared answer, we did the same thing. We extended that. See, you needed a construction to solve the problem. And let's see what answer we came to in this situation. It's also 7. There we go. Okay, so this is the correct answer. All right, so let's get on to the next problem. Problem number 23. A large rectangle ABCD is split into two smaller rectangles. Okay, so you've got it's broken up into two pieces. One is 40 and the other 60. So the area of the rectangle is 100. Okay. If the side lengths of ABCD are integer values, so the side length of this rectangle are integers. So let's call this A, and let's call this other one B. So they are integers, positive integers. They have to be positive. They are sides of a rectangle. Determine the smallest possible perimeter of ABCD. Okay, in other words, what's the perimeter? The perimeter of a rectangle is 2 into length plus breadth. This is one of the first formula you learn. So it's 2 into length plus breadth, which is A plus B. So in other words, we want to find this as small as possible, the smallest possible perimeter. Now I've drawn a little table here where I observe that A times B is the area of the whole rectangle. So that is 100. It's 40 plus 60. And they are integers. So let's work out all the possible integers whose product is 100. I've written the whole lot of them down. See, there's A here, there's B. So you have 1 times 100. So 1 is a factor. So these A and B are factors. So the next factor will be 2. It's an even number. The other factor will be 50. 4 goes exactly into this, 4 times 25. 5 also goes into this, 5 times 20. But after that, none of 6, 7, 8, 9, 10 goes, but 10 goes, and it's 10 times 10. It's a perfect square. Right? The next factor is 20, and 20 times 5. So you can see I've got this pair A and B. In this case, A plus B, we're looking for A plus B, is 5 and 20. Yeah, it's 20 and 5. So if you go on, you're going to have 20 and 5, 25 and 4, 50 and 2, 101 in the top line. And I didn't care to finish that off because I'm looking for the smallest possible perimeter. And when you look at the perimeter, which is 2 into A plus B, that's in the third line. I calculated it. So I calculated the perimeters. I see the perimeters are getting smaller and smaller and smaller until it comes to this part here. It's the smallest possible value. Well, smaller, but now it starts growing. And I told you that these numbers here will now be repeated on the other side. So this guy is the smallest perimeter. You can see it from the diagram, right? If you want, you can complete this thing, but it's really not necessary because the next, you see, the factors come like this: 1 times 100, 2 times 50. Once you come to 4 times 5 times 20, and 10 times 10. So when you write it down like this, you can see all the possible factors. It's 1, 2, 4, 5, 10. Now you get 10, 20, 25, 50. So there are 10 factors only, right? So you're gonna get these things repeated. All right, so that takes care of problem number 23, right? So we have only 2 more left. Let's just check to see whether the answer is indeed 40, because often I make calculation errors. Let's get on to the the minimum perimeter is 40. Right, so I got exactly the same thing. Well, the diagram earlier on was the same diagram. Okay, let's get on to the next problem. Problem number 24. Problem number 24, let's read this. It says that Kamohelo finds the sum of 2 digits of a 2-digit number, as well as a product of the 2 digits. Let's just stop right there, and we'll say that we don't know what the 2-digit number is. I'm going to put it as the tens unit is A, and the units digit is B. So sometimes I write it as AB, but it's confusing because this looks as if it's a product. So this is your number, your 2-digit number. Its actual value, if you take 37, in terms of the digits, these are called the digits. 37 is, you got 10 threes, because this is the tens unit. So it's 3 times 10, right? And then the units is 7. So 10 3 is 30. It's 30 plus 7. So if you got A and if you got B here, so it means that the value is 10A plus B. That's the actual value of this two. So this is the two-digit number. When you write it, it looks like that. Now, he finds the sum of the two digits of the two numbers. So he calculates, Kamuhelo calculates A plus B. That's the sum of the two digits. And also the product. Okay, so now that's, so when you calculate the product is AB. So just as well, I didn't write this like this, because you need to know what the product of these two is. So he calculates these two, and then she adds the sum to the product. So she adds those, this is the sum to the product, and realizes that the result is actually equal to the two-digit number itself. Right? So when she calculates this, she comes to the original value. So now this two-digit number is 10A plus B. So there it is. You got a formula. So if you in which has got the two numbers A and B. So when you read it like this, now you see you get a lovely formula. Okay, A plus B plus AB is 10A plus B. So you need to calculate how many two numbers would be the case. How many A and B satisfy this equation? How many pairs? We'll call it pairs A, B satisfy this. Satisfy the above equation. So let's try to solve this. You'll notice that you got A plus B, so the B's actually cancel. B is okay on both sides of the equation. So you have A plus B plus AB, and you got A here and you got 10A here. So you got 10A minus AB equals 0. Oh, wait a minute, 10A minus A. Okay, 10A minus A is 9A. So let me replace that 10 straight away by 9. So this is the equation you have. And you see A is a common factor. So A into 9 minus B is equal to 0. And so you got the product of two numbers equal to 0. So one of them is necessarily 0. If you got two numbers and you multiply them, and the answer is 0, one number has to be 0. Well, you can try it out. So can it be A? No, it can't be A, because A is the first of these two digits. And it says it's a two-digit number. So you can't very well have a 0 in front of a two-digit number. Then it becomes a one-digit number. So A is not 0. So the other one has to be 0. And that tells you that B is equal to 9. Okay. Now, if B equals 9, it doesn't really matter what A is, because 9 times any number is 0. So A is random. A is any. But not quite. A is a digit. So A will have to be equal to, it's not 0. It could be a digit, which is 1, 2, 3, 4, 5, 6, 7, 8, or 9. So A could be any one of these, but B will also always have to be 9. Right? So in other words, the numbers, these two-digit numbers are if A is 1, you have 19, 29, and so on, all the way up to 99. The B always remains at 9, but the A can be any one from 19 to 29. Okay, so that's the So how many are there? So there are 9 possibilities, because they ask you how many. Always answer the question. How many two-digit numbers will be the case? And the answer is 9. Because you can see A runs from 1 to 9. So there are 9 possible answers. Let's just check this thing out, because if you go back to your original problem, it says that these 2 digits have got a very interesting property. Let's take any one of these solutions. Take 49. And what makes 49 work? All right, suppose you take this 2-digit number. What does Poobhalan do to this number? She adds the sum. She takes 13, 4 plus 9 is 13, and she calculates the product of these two, 4 times 9. She also calculates the product and the sum, and then she adds these two. She adds these two, and she realizes that the result, 36 plus 13, is actually equal to the original number that we started off with. So you can see it works, right? It works for 49, and if you try it for all the others, it'll work also. So that's very nice. You got 9 possible 2-digit numbers, which will do the trick. Okay, so I've all right. So this is the solution. Let's clear this thing out. You can see I've got the same kind of solution, and at the end there are 9 such numbers. All right. So let me move on to the last question, question 25. Okay. So what does this question say? It says that there are 5 cards in a bag, and there is a whole number written on it. So you got 5 cards inside a bag, and there's a whole number which is written on it. Whenever 3 of these cards are chosen at random, we find the following probabilities. The probability of P% is that the sum is equal to 14. Okay, let's call these numbers A, B, C, D, E. So we pick any 3 of these at random, right, chosen, and then we calculate the sum of these 3 numbers, right? So I've written down all the possible ways here in which you can take 3 of these cards. You can A, B, C, then the sum is A plus B plus C, or you could have, see, there's a way of listing these. I put A, B, and then I put C, and then A, B, and D, then A, B, and E. So I take the first 2 and fix them at A and B. Then I take the first 2 and fix them at A and C. So A, C, now we finished with all the A and B together. So A and C, and then it'll be D, A, C, and E. Right? And then after that, I take A and D, and so on. And you will see that there are 10 possible sums. Okay. Now it says the probability is P% that the sum is equal to 14, and 100 minus P%, the sum is 15. This looks very complicated. But what we are saying here is that the sum is 14 in this case, and this is the only other sum is 15, because these two add up to 100%, you see. So there's no other sum. There are only 2 possible sums. So there are only 2 possible sums. In other words, there are not 10 numbers here, there are only 2 numbers. Okay? And they are either 14 or 15. So you've got only 2 numbers. All right, now, so what about these are the sums now. So A, B, C, D, E, right? When you add any 3 of these, you're going to get either 14 or you're going to get 15. Now, I just want to point out here that you can't have 3 different numbers. Okay, let's say you can't have A and B and C all to be all different. Right? Suppose all different. If that is the case, then you'll have, like for instance, you'll have A plus B plus C is one answer. And you'll have A plus B plus D is another answer. And you get A plus B plus E is a third answer. Now these will all be different because you got these sums will be different. So you'll have 3 different sums. This will give you 3 different sums. So you can't have all 3 of them different. So you'll have to have that there are only 2 such numbers. So there are only 2, or maybe 1, right? Okay. So suppose you say that the numbers are A, and then yeah, actually this argument here is not right. Let's just ignore this argument. Sorry. So suppose you got 3 different numbers in the set, right? Then you're going to have these sums here. You're going to have A plus A is one sum, and you'll have A plus B plus C, or if you like, you have let's make it A plus B plus C, and you got A plus B, and you will have A plus C. A plus A. So then these will all be different, as you can see quickly, because A is not equal to C, so these 2 will be different, and those 2 are also different, because B is not equal to, these 2 are, B is not equal to A, so these 2 will be different. So you have 3 different sums. Okay, so you have only 2 numbers, in other words. So this is not possible. So you could have had 3 A's, you could have B and B. So it's quite possible that you could have only 2 different numbers. But in this case here, you'll have that one of the sums, or you could have had only one number, A, right? That is also possible because any 3 of these will give you the same thing. But in both cases, you have that there are 3 A's. So one of the sums is A plus A, right? And that is 3A. But what you got, the sum is 14 or 15. So 3A can't be 14 because A is a whole number. Right? The cards have got whole numbers. So this have to be 15. So you have that A is equal to 5. In both cases, there's a possibility of 3 A's. But if A is 5, then you got all these are 5 here, and you can't have the sum 14 because the only sum you can have here is 15. So this possibility is out. Okay, because you have 14 doesn't appear. So you have 2 B's or no B's, but you could have 1 B. Forget about this. You could have 1 B. All right, so no B's is out. Now what about 2 B's? Now here you will have, now we said that A is 5, right? A will have to be 5. So you got 5, 5, 5. And the sum is 14. So 5 plus 5 is 10. So the next one, B will have to be 4. Right. So if A is 5, then B will have to be 4 to get the sums for 15 and 14. But notice that in this scenario, I've got the sum 5 plus 8. 5 plus 4 plus 4 is allowed in the first scenario. And that is different from the two sums that we have. So this is also out because that gives you a new number. So the numbers that we have, 4 of them are the same, and 1 is different. The numbers which are the same are all 5s. So we now know exactly what A, B, and C are. They are. The 5 numbers. The numbers are 5, 5, 5, and 4. Okay. Now, they say the probability is P% for the sum to be 14. And so for the sum to be 14, how many times do you have 14? Okay. In other words, this one single number must be, suppose A is 4, right? So you have an A here, you have an A here, you have an A here, an A here, you have an A here, you have an A here, right? So you got 4 and the others will have to be 5. So there are 6 of them, which gives you 14. Right? No A's in the other case. So 6 of the sums will be 14. 6 sums of 10 is 14. So the probability of getting the sum 14 is 6 out of 10. So the probability the sum is 14p is equal to 6 out of 10. Because in this case where A is 5 and B is 4, that is what we have concluded. There are 6 situations where the sum is 14. So the P% is 60. This is a calculated value of P. The answer is 60. It's quite a challenging sum, but it's the last because we are 25 now. So the last problem is usually the most difficult one. So, so that is the answer to this question. And I'm sure that this is the okay. So I don't think this is complete. The argument that you have only one, the numbers are going to be 5, 5, 5, 5, and 4, right? But It's a shortened argument. All right, so that's the last problem. Thank you very much for listening and enjoy the rest of the day.